All right, today we're doing a deep dive into something of a paradox. We're looking at the Thor Broadcast H-16RCA-RF-AMOD.
Yeah, and it's a fascinating one because on paper you see this and you think, analog. This must be obsolete. The sources even call it quickly becoming legacy equipment.
Exactly. In a world of digital streaming, IP everything, why are we talking about an analog head end?
Well, that's the mission, isn't it? To figure out why this high-density 16-channel modulator is still so important, it turns out there's a huge ongoing need for this kind of bridge technology.
Okay, so let's get into the specs. At its core, what is it?
It's a 16-channel analog agile modulator. And agile is important. It means operators can, easily shift frequencies around.
And it's universal?
It supports NTSC, PLL, and SECAM. So basically all the major worldwide analog standards.
What really jumps out at me, though, is the density. 16 channels in one box.
In a single rack unit, 1 RU space. That is huge for simplifying a server room that's already crowded. 16 independent inputs.
And those inputs are, well, they're definitely old school. We're talking CVBS, RCA jacks.
Right. No HDMI here. This is all about baseband video and audio. It's the perfect bridge for older source equipment.
Like what specifically? What are people plugging into this?
Oh, all sorts. You've got older security cameras, for one. A lot of facilities still have them. Then DVD players, VCRs, set-top boxes.
And I saw mention of even classic gaming systems.
Absolutely. Think about a university or a collector who needs to distribute a signal from a classic Nintendo 64 or an original PlayStation. This is how you do it professionally over a coaxial network.
Okay, so it's a bridge. But the real story here seems to be its power. How much broadcasting power are we actually talking about?
A lot. This is what makes it a professional tool. The sources point to its high-power RF output. It's rated at 113 dBA.
Which, for people more familiar with millivolts, is?
That's plus 53 dBmV. And that number, that sheer power, is the main selling point.
So why is that brute force so critical?
It's all about economics and infrastructure. If you're a hotel, a school, a hospital, you have miles of coaxial cable already in the walls.
Right.
With that high output, you can feed a video signal to hundreds of TVs on that existing network without having to install a bunch of external RF amplifiers.
So it saves money, time, and I imagine a lot of maintenance headaches.
Exactly. It's a huge value proposition. A single powerful source instead of a daisy chain of potential failure points.
The sources also mention SAW filtering. For our listeners who know their RF, what's that doing for the signal?
Surface acoustic wave filtering. It's essential for keeping the channels clean. It basically creates a very sharp filter so that when you pack all 16 channels right next to each other in the spectrum,
they don't bleed into each other.
Precisely. You get clean adjacent channels across that whole CATV RF band from 45 to 870 millihertz. Set it and forget it.
So if you're an operator, why not just go with a modern IP-based system? Just bypass this analog step entirely.
Capital expense. I mean, it's that simple. An IP system might mean ripping out all that perfectly good coaxial cable and running new Ethernet, buying new encoders, new TVs.
A total and very expensive overhaul.
Yeah, a massive one. This solution leverages the infrastructure that's already there. It's high performance for what it does, but at a much lower cost than a full rip and replace.
The sources also pointed to some interesting secondary uses, like creating private anonymous channels. How does that work?
Well, it lets you create your own little closed-circuit TV network. You can inject any content you want, security feeds, a school's morning announcements, a hotel's information channel.
Or even an internal music or radio channel.
And it goes right onto the building's coax network, totally separate from the outside cable company's signal. Anyone with a basic analog TV can just tune to that channel. It's simple and it's secure.
So, to wrap this up, we've taken a deep dive into the Thor H-16RCA-RF-AMOD. It's a real workhorse, isn't it? A high-density, high-power unit designed to get older analog signals onto a massive coax network.
Yeah, and I think the real takeaway for you listening is this. Technology is very rarely just replaced wholesale. It becomes specialized. The fact that things like CDBS and analog RF are still around isn't a mistake.
It's a function of economics.
It's a function of economics and the reality of existing infrastructure. So the next time you think about legacy tech, consider this. Backward compatibility in these big professional settings isn't a bonus feature. It's an absolute operational necessity.